Alright, good morning ladies and gentlemen. My name is Prejan Hadiahan. I am a master student in Informatic Engineering, Universitas Sumatera Utara. As for I'm talking about here, I want to present my research entitled Hybrid and Colony Optimization and Particle Swarm Optimization for mid-span minimization in job shop scheduling problem. Introduction. So, the background issue in this research is the scheduling problem, which is one of the common challenges in various industries. Many industries face scheduling constraints that can impact operational smoothness, such as uneven machine work time, the presence of idle machine, and an exercise machine wait time. The impact of this issue can diminish the quality and custom of production. Additionally, max span, the total time required to complete a job, plays a crucial role by minimizing max span. It is anticipated that production costs can be reduced, completion times accelerate, and overall production quality and outcomes improved. The job shop concept is also relevant, where job shop scheduling involves the process of determining optimal time for executing production tasks on one or multiple machines, with the goal of reducing job completion times and production costs. Then, for our research graph, it is depicted in the following picture. In this diagram, there are 5 jobs and 4 machines. Each machine can only process one job at a time. The operations within a job are connected by conjunctive R, solid line in graph G, which are members of set A. There are represent the condition in the job shop problem formulation. The sequence of operation in a job is indicated by arrows, and the sequence cannot be changed. Job 1 consists of operation 1 and 2. Job 2 consists of operation 3, 4 and 5 and so on. The immediate predecessor or the operation preceding operation 4 in job 2 is operation 3, the immediate successor. The immediate successor or the operation following operation 9 in job 4 is operation 10. The operations performed by a machine are connected by disjunctive R, digit lines in graph G, which are members of set E. These are represent the condition in the job shop problem formulation. In the graph, the sequence of operation on each machine has not been determined. Operation 1, 3, 6, and 9 are performed by machine 1. Operation 2, 5, and 7 are performed by machine 2, and so on. Next, Propius model, the stage of the research method that we conducted were selecting the job shop scheduling problem data, namely the tailored dataset that will be used for testing. Read the routing job, including the machine and job for each dataset. Calculate the P-base value, namely the process position of each job on the machine, to get the best solution with the particle swarm optimization algorithm. Next, calculate the global base or G-base value the position of each job on the base machine on the whole machine with the particle swarm optimization algorithm. Next, analyze and colony optimization parameters by using personal base and global base. particle sum optimization values. Search for the best routing for each job with the n colony optimization algorithm. Display the scope of each job. Next, display the routing job with the minimum. Display the routing job with the minimum span. Next, n colony optimization. In solving scheduling problem using the n colony optimization algorithm, there are their stages that need to be carried out. 1. Parameter initialization. The parameters that are analyzed are the intensity of an trial between router and their change, IG, also called pheromones. The number of router, neck distance, pause between router. In case of distance between nodes or time difference, in case of job of close-up, determination of the source and destination router. Next, and client setting of entrail intensity, control, visibility control constant, visibility between router, number of n, evaporation rate of entrail, and then the maximum number of cycle is fixed as long the algorithm is running, while the IG is updated in each cycle of algorithm, and starting from the first cycle until the maximum number of cycles is reached or until convergence occurs before the arms move. These are placed on the first predetermined router. Next, particle sum optimization. Some common terms used in particle sum optimization can be defined as follows. Swarm, the population of an algorithm. Next, particle, a member individual of a swarm. Each particle represents a potential solution to the problem being solved. The position of a particle is determined. The position of a particle is determined by its current solution representation. P-base or personal base, the base position of a particle, which indicates the position of the particle that is prepared to obtain the base solution. G-base or global base, the base position of a particle in the swarm. The scheduling process requires input data, including the type and quantity of jobs to be processed, the sequence of operation and dependencies between operations, and the processing time for each operation. In job subproblem, a certain number of jobs needs to be processed on a certain number of machines. Each job consists of several operations that need to be processed on different machines. The next step is to calculate the time difference between the machines for each job. Then the P-base and G-base values are calculated and analyzed in the n colony optimization process. In the n colony optimization routing finding process, the destination of the order, whether it is to point A or B, machine A or machine B, is determined by calculating the probabilities using a specific formula. Once the routes are determined, the corresponding max span value is obtained. Result is ordered to assess the reliability of the developed application. Tests were carried out using secondary data from a tailored benchmark from basic scheduling problem. The dataset consists job machine of size 4 job 4 machine, 5 job 5 machine, 7 job 7 machine, 10 job 10 machine, 15 job, 15 machine, 20 job, 20 machine, and then 13 job, 30 job, 50 machine. The job solve problem were solved using the hybrid and colony optimization and particle swarm optimization algorithm. The dataset from tailored benchmark problem can be found in the appendix. Each dataset was processed 10 times for each algorithm with predetermined parameter. As the dataset size increases and become more complex, the mixed span result with the N-colony optimization and particle swarm optimization algorithm improve, showing an average mixed span improvement of 0.660. In this study, a performed analysis of hybrid and colony optimization and particle swarm optimization algorithm has been conducted to minimize mixed span in job scheduling. The dataset processed in taking from a tailored benchmark for basic scheduling problem. The research result for dataset of size 10 job 10 machine, 15 job 15 machine, 20 job 20 machine, and then 30 job 50 machine. So a reduced mixed span compared to the lower bound algorithm uses a tailored dataset with an average minimum span improvement of 0.660. So the result of our presentation, if during the delivery of our speech is wrong, please forgive everyone and thank you.